Let's take a look at some of the work we did with scientific notation today. Make sure everybody knows how to do it. First of all, if you're putting numbers into scientific notation, what you're going to do is you're going to move the decimal point so that there's one number in front of it. So 0.005 changes to 5. It'll be times 10 to some number. That exponent is determined by how far you move the decimal point. We move the decimal point in this case 1, 2, 3 places. Now that exponent will be either positive or negative based on which direction we went. In this case, we went to the right. When we go to the right, we get negative exponents. Right equals negative exponents. We're going to maintain significant figures as we do this. We have one significant figure here. With our scientific notation, you just look at the number in front. It has one significant figure in this case, so we know we don't have anything to worry about here. One when we start, one when we end. Significant figures are fine. Again, what we got to do is move the decimal point so there's one number in front of it. If there's no decimal point, assume it's at the end. We need to move it there, so there's one number in front of it. As I said, maintain significant figures. This has 3 significant figures because the trailing 0 doesn't count. So it's 5.05 times 10 to some power. We moved it 3 places again. 1, 2, 3. We went to the left this time. When we go to the left, it is going to be a positive exponent. So it just stays positive 3. Once again, move the decimal point so there's one number in front of it. It's going to go to where the 8 is, right after the 8. One significant figure here. Write down one significant figure in your scientific notation. Times 10 to some power. We moved it 1, 2, 3, 4 places. We went to the right, so it is negative 4. Again, if there's no decimal point, assume it's the end. Move it so there's one number in front of it. One significant figure here, 1 in our scientific notation. So we just write down 1, not 1.0, not 1.00, just 1. We moved the decimal point 1, 2, 3 places. We moved it to the left so it stays positive. That's how you put them into scientific notation. To take them out of scientific notation, you do the opposite. You got the positive exponent by moving to the left. To undo it, you got to go to the right. So we take 1.5, move it 3 places to the right, fill in the empty spaces with zeros, 1,500. I have a negative 3 exponent. To get a negative exponent, I moved it to the right. To undo it, I have to go to the left. So I take the 1.5, move it to the left 3 places. Fill in the empty spots with zeros, 0.0015. We do want to maintain significant figures here. I have 2 significant figures here. Make sure you still have 2 in your answer. I have 2 significant figures here. Again, make sure you still have 2 in your answer. So again, just undo what you did. To get a negative exponent, you went to the right. To undo it, you're going to have to go to the left. So 3.75, 2 places to the left. Fill it in with a 0. 0.0375. To get a positive exponent, you moved to the left. Undo it by going to the right. We're going to go to the right 2 places. It's going to be 375. We have 3 significant figures there. We have 3 there. We have 3 significant figures there. We have 3 there. The harder part is going to be the math. Knowing how to deal with those exponents if you don't have a scientific calculator. If you have one, you just punch it in. You're going to use a calculator in the class, so let it do the work. If you don't, you have to know how to work it out. In addition to subtraction, you have to make sure your exponents match. I have a 10 to the 5th, I have a 10 to the 6th here. I have to make them the same number, and I suggest going with the larger number. You want to make that 5 a 6. If you raise it, you need to move the decimal point that was in that original number to the left. If you lower, and you can do that, you could lower that 6 to a 5. If you lower it, though, you're going to have to move that decimal point to the right. I'm going to raise. I'm going to go for the higher number. And the reason why I'm going to go for the higher number is because most of the time it works in scientific notation. You get your answer in scientific notation. It's nice and neat. So because I raised this by 1, I'm going to move this decimal point to the left 1. So that becomes 0.12 times 10 to the 6th. At that point now, I can just go ahead and add those two numbers together. So I do 5.35 plus 0.12. I get 5.47. One number in front of the decimal point. That's what I like about raising the exponent. You usually end up with one number in front of the decimal point like you need in scientific notation. And we chose 10 to the 6th. As far as significant figures are concerned, we have two numbers after the decimal point here, two numbers after the decimal point here, two numbers after the decimal point in our answer, so everything lines up like it should. Remember, adding and subtracting is about numbers after the decimal point. We get down here, subtraction, it's going to be a similar process. I've got a 2 and a 1. I need them to match. And again, I'm going to opt for raising the lower one, getting them to match the higher number. Because usually that gives us an answer that's already in scientific notation, and it's less work for us to do in the end. Because I raised this by 1, I do have to move that decimal point to the left again. 0.16 times 10 to the 2. I can go ahead and subtract the first two numbers, 3.67 minus 0.16. I get 3.51. Two numbers after the decimal point, two numbers after the decimal point, two numbers after the decimal point. It all works out nice and neat. Significant figures are good. Times 10 to the 2. When you multiply and divide, it's a little bit easier because you don't have to worry about making the exponents match. When you multiply, you're going to add. When you divide, you're going to subtract those exponents. You do whatever it tells you to do to the first part. So we're going to do 4.3 times 2. That gives us 8.6. Significant figure-wise, this is all about the number of significant figures. Two significant figures here, two significant figures here, two significant figures in the answer. For the exponents, because I'm multiplying, I'm going to add them together. So I'm going to do 8 plus 6, and I'm going to get an exponent of 14. That's it. I'm done. No reason to change any of the exponents, just in the case of multiplication, add them together. When we divide, we're going to subtract the exponents. Again, similar story. We're going to go ahead and do what we need to do with those two numbers. We're going to do 7.8 divided by 1.2. And we're going to get 6.5. Two significant figures there, two significant figures there, two significant figures there. Everything already lines up as far as the significant figures go. For the times 10 part, again, we're going to subtract those exponents. 3 minus 4 is negative 1. So 6.5 times 10 to the negative 1 is the answer. Again, we're going to subtract when we divide. We're going to add the exponents when we multiply.